Hello, my name is Alessandro Simone. I'm part of Team 4 alongside Sebastian Lahens, Arslan Raleigh, as well as Rebecca Navetta. This is the functional visual field analyzer, but before we get deep into each component, it's important to understand what the test generally does. First, the patient is mounted into the device in a position where the forehead and the testing paper form a 90-degree angle. Once this is done correctly, the physician may insert targets from either the right side or the left side, in which the patient may report seeing, and then data is recorded. This data is then used to monitor the patient's treatment overall, as this is a diagnostic test. Now that we know the general idea of the project, we can dig deep into each component. We're going to go ahead and start with the harmless distance system, and it's important to understand that harmless distance is something relative to each patient. This means that it's a distance between the elbow to the wrist, which changes generally from person to person. We have created a system made out of 2 steel rods, an inner rod as well as an outer rod. In order to adjust, perhaps needing a larger harmless distance, a pin is retracted, the harmless distance is extended, and the pin is then inserted one more time. This locks the distance into place with increments of 1 inch. In the case that perhaps we're testing a children, someone with a smaller harmless distance, we have also created a second rod, which ranges from between 6 inches to 11 inches, or using the larger rod, which ranges between 9 inches to 14 inches. In order to attach the harmless distance system into the device itself, we have created a 23-degree cut at the bottom of the rod, which is congruent to that of the device, in order to maintain a 90-degree angle between the system and the testing paper itself. Both rods are steel in order to be able to maintain the weight of any patient pushing against the device while testing. Again, retracting the pin, adjusting for the height, inserting the pin one more time in order to lock into place. One of the main problems in the current modalities is keeping a constant head positioning. Due to this, we have created a unique headpiece that involves a cross input as well as a cross input slot for the harmless distance. This creates a perfect fit, which guarantees a consistent head positioning while testing for each patient. There are 2 headpieces. One, a small one, perhaps for children, which ranges from 17 inches to 21 inches in head circumference, and a bigger one for adults, which ranges between 19 inches to 30 inches in head circumference. Since we are working with patients with TBIs, it is important to not strap up the patient to the device and instead create a quick release mechanism. We have achieved that by creating a mechanism that allows the patient to retract themselves from the device at any given moment with ease. The headpiece itself is also equipped with padding across the sides, as well as Velcro straps in order to accommodate to different patient head sizes, as patients must endure testing between 15 to 20 minutes. Apart from head positioning, the physician may also want to adjust the paper. Perhaps this testing a children, where the paper must be raised all the way up in order to accommodate to their small size, or perhaps it's an adult, where the paper must be brought down all the way to the bottom. Most patients will not only test for one eye, but the physician may also retract the paper, flip it, and test for the other eye by inserting it comfortably across the paper liners. Lastly, it's very important to understand that there are several constants that must remain the same in order for the test to be valuable. Number 1 will be 23-degree angle between the surface and the testing paper created on this corner. Number 2 will be a 90-degree angle between the testing paper surface and the backboard. This is in order to guarantee that the harmless distance system fits comfortably inside of the device. Number 3 will be a 90-degree angle between the testing paper as well as the harmless distance system. The materials chosen are plywood as well as steel, as we must be able to endure up to 20 pounds of force exerted on the device at any time during testing. The device itself weighs around 13.8 pounds, which allows it to be very portable. The device also includes an anti-slip silicone sheet in order to increase friction and increase drag while testing. This is due to the fact that children, or perhaps adults, do exert force more than the head weight when testing. We must allow the device to remain stable and not be shifting in order to guarantee accurate results. Thank you. My name is Alessandro, and this is Team 4, Functional Visual Field Analyzer.